So we've got a rocket being fired up, I think it's question 16. A rocket being fired up at 50 meters per second vertically, and it's got a deceleration. When we read that, what are we automatically thinking? What type of problem is it? What type of problem? Kinematics. So before we go any further, we know we're dealing with kinematics and that kinematics ladder, correct? So if I was to draw over here a kinematics ladder, up the top I had distance or displacement, velocity, and acceleration. Yeah. Position, displacement, the whole lot. There's heaps of different words. Velocity is the same as speed. I can't promise it'll come in any form. You've just got to be good enough to know which one's which. I wish we'd use one language, but that's not how it works. And it's not how it works in your external, so we shouldn't be setting up for failure. So if I'm going down the ladder, what am I doing? Deriving. And if I'm going up the ladder, integrating. So it's always a good idea when you've got a kinematics problem to draw that little ladder up. Remind yourself. 9.8 deceleration. I should have finished it off. Okay? So, always draw that. What's a hint that we can get? If we're not sure that we've drawn the ladder, we don't know whether going down is deriving or integrating, we've forgotten. What's a hint? We look at the units. Sorry, that wasn't okay. So if I look at the units for distance, what's a unit for distance? Meters. What's a unit for velocity? Meters per second. D, now I've got dx, but it's really with respect to time. We're always deriving these with respect to time. How your position changes over time. How your speed changes over time. Cool? So as we're going down, we can see we're getting that dt, which is our change in time. So look at the units, use that as our guide. But back to this question. It asks us to develop a velocity equation. So I want us to all develop a velocity equation. You've got all the information you need. You could, but yeah, you can. You can. Just be aware that when you get the plus C, you might have to think about it. Let's do it that way. We'll go Case's way. What's my acceleration? Negative 9.8. Correct? Does that change over time? So it should always be 9.8. So it's a constant, negative 9.8. Velocity equals my integration of acceleration. Correct? What does that equal? Negative 9.8t. Do I know anything else? Good, you passed the spelling test. Shh, I know it's not spelling. I also know that initially the velocity is 50. So I know that 50 equals negative 9.8 times 0 plus c. C must equal 50. So my velocity equation, Vt, equals negative 9.8t plus 50. Does that make sense? I'm going to almost certainly guess the next thing it asks us to do is to find out displacement equation. Because we've got our acceleration, we've got our velocity. How will we find our displacement? We will integrate our velocity. So you could call it xt or dt or whatever you want to call it. And that will become negative 9.8t plus 50 dt, which equals negative 9.8 t squared over 2 plus 50t plus c. It's going to be gross, I hate this pen. Does it have any other information in the question about initial position? Actually, I haven't got the question. It starts on the ground, does it?
At t equals 0, the position is 0?
Yep, so at x of 0, that's xt. Because it says it starts on the ground, x of 0 equals 0, which simply means c equals 0. So we don't actually need this part here, but we should have checked to see that. It might have started on a 2 metre cliff, in which case c would equal 2. What does it then ask us to do? At a point in time, what's the?
20 meters above the ground.
So it says at a point in time it's 120 metres above the ground. So what do I need to do? Let xt equal 120 and solve for? What's that going to look like? What type of problem is it going to be? A quadratic? I'm running out of room, but I might do it over here. Oh, this is going to be gross. Yeah, this is absolutely a graphics calculator. What do we need to be mindful of with kinematics? Always need to be mindful of? What if it's at 120 centimetres? Would that change something? Need to be mindful of units, correct? So if it's at 120 centimetres, it'd be 1.2 metres, not 100. Just keep your units the same. So here, what are we dealing with? What are all these dealing with? Metres. So I'd have to convert whatever I'm dealing with into metres. So I've got 120 metres, you said? 120 equals xt. So 120 equals negative 9.8 t squared over 2 plus 50t.
T equals 3.86, 6.34.
I'm just going to make this negative 4.9 t squared. I hope we're happy with that. Oh, well, that's good. Thanks for letting me know. Genuinely, thanks for letting me know, because most people don't. So there's our problem. There is no way we can do this in an exam without a calculator. So this would absolutely be a tech free. I would simply graph this or use solver and find out where it equals 0. What are the solutions for that? Let's find that out.
3.86.
T equals 3.86 or 6.34. I need to put my units in, seconds. It asks what's the first time it hits it, so I'm going to guess it asks that anyway. That's our first time. One on the way up, one on the way down. Anything else in that question? Don't think so. Are we clear on how those kinematics questions work? It's really like, is that very hard? What's the challenge? Identifying what you're looking for and finding information. So most of us would have struggled to find that C value. How do we know to find that C value? Well, when we see initially fired at 50 metres, initially means let time equals 0. If it starts at rest, what does that mean? When time equals 0, your velocity is 0 metres per second. If it starts at its origin, what does that mean? Or at ground level, or whatever it might be. You let x equal 0 when t equals 0. Sweet? Cool. I'll leave you to it.